I guarantee they couldn't be slumbering because you guys are all so noisy. You can't eat up my 15 minutes with song.
We can do this for
Although it shouldn't take us 15 minutes.
Let's talk about math. Let's talk about math.
Feel free to fast forward through this section.
No, you know you won't. That's how we go back.
All right. Second row.
All right, we're done.
What about this problem says to you, I need to be U-substituted?
Well, there's the small and the high power.
Okay, so there's a quantity to a power, which is right now the only thing you know about U-substitution. There are actually many other places where you substitute, but today it's quantity to a power is your dead giveaway. So, yes, what would you like to U-substitute? U equals what here? 4 minus 3x squared. Okay, now, you need to learn to do this faster. You may instantly know you're going to have to do the derivative of that. So as soon as you write up the substitution, I highly recommend that you just go, oh, the derivative of that will be what? Negative 6x. You're going to have to always multiply the dx over there, so you might as well just put it over there to start with. And so therefore dx is going to actually equal du over negative 6x. You always need to solve it for dx so you can replace it in the original problem. Okay, so now, put the substitutions in. Is the 3x still on top? Is it a u? What happens to the 3x?
Definitely a U. You have to change everything to
That u right now is the quantity 4 minus 3x squared, so on the bottom we have u to the 7th.
Yep. Oh, because it'll cancel.
We hope it will cancel. We'll learn next class what happens if it doesn't cancel. Because they don't always cancel. So, yes, in this case, is it going to work out? We're going to get to ditch it? Yeah. The x's are gone. 3 cancels into 6, 2 at a time. So actually we got a negative 2 left. Okay. With antiderivatives or integration, if you have constant numbers, this is really being multiplied by a half then, a negative half. You can choose to take constant numbers like that. In this case, I would recommend it. You can just throw any constant numbers that are multiplied in there, just throw them out front. Because they really aren't doing anything but sitting there anyhow. Do I want to leave the u to 7th in the denominator? Can you do the power rule that's down on the bottom? No. You've got to bring it up to do the power rule. So we have to have u to the negative 7th. And once again, it's a whole lot cleaner once you get that substitution done. So now can you do power rule? Yep. So if I add 1 to the power, that would be u to the negative 6 over negative 6. Thank you. Was waiting for that. Plus c. Okay. So I got a little bit of issue here. The 2 and the 6 multiply. And we get 12, and actually the 2 negatives make a positive. So the 12's on the bottom. Where does the u need to be? The u also needs to go back to the bottom, but I need it to not be u anymore. So I need that, yes, the u gets replaced with the original substitution of 4 minus 3x squared to the what power? To the 6, and that's all on the bottom. Probably should move my 1 over now. So it ends up kind of a strange quantity there on the bottom with r plus c. The key thing is you can never, ever, 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 ever do antiderivatives or integration with 2 different variables. It's all got to be the same variable. Ever. Did we get that message?
Never.
All right. All right. Brief review here. before we take this backwards, the other thing we need to do today is remember our basic derivatives of our friends, the trig function. What's the derivative of sine? Cosine. So when we start to do this in reverse, now you're going to be given the derivative of cosine, or excuse me, the antiderivative of cosine, and you are going to have to come up with what answer? Sine. You got to think backwards here. So you'll actually end up with sine of x plus c. That wasn't bad. That was the problem. No, you would be bored and it would be too easy, and then people would think calculus was easy.
Then you have more students, and you'd be able to keep.
That's true. I'd have more students. Okay. Now, when you see this done in reverse, though, it's not going to be, hey, what's the antiderivative of negative sine? It's just going to be, hey, dude, what's the antiderivative of sine? So, if doing the derivative of cosine got me a negative sine, it will give you a negative cosine, yes. The negatives are going to play with your brain a little bit. Okay, if the derivative of tangent was secant squared x, then we know when you're asked to do the antiderivative of secant squared, you're going to get tangent. Okay. That one's fairly obvious. And if the derivative of cotangent is negative cosecant squared, what's the antiderivative of positive cosecant squared going to be? Negative cotangent. I am. I want to get on with this. And if I write fast enough, you'll have to be quiet and keep up. Okay. But you should know your derivatives. What is your derivative of secant? Derivative of secant is secant tangent. So what are they going to ask you to do the antiderivative of? You'll be given the secant x tangent x, and you will have to go back, and it will become a what? It will become a secant. And I do have a trick for you to remember how you know about the negatives here as soon as we get all these written out. Last but not least, cosecant's derivative was negative cosecant x cotangent x. And so, of course, they're going to ask you to do the antiderivative of the reverse, which would be cosecant x cotangent x. I heard a minus cosecant. Are we buying that? Okay. Like I said, what plays with most people's brains on the trig function is the, okay, what do I do with the negatives now? Notice, when we did derivatives here on the left side, you always put negatives on when you did the derivative of a co. You put a negative on it. Now, anybody see when you put negatives on your answers? It's when you got a co as an answer. If your answer came out cosine, cotangent, or cosecant, you put the negative on it. So it's when, because you start out with all of them being positive. If you get a co in your answer, it gets a negative. Right. Two others on here. What was the derivative of e to the x? Don't all jump on that one at once. So, what's the antiderivative of e to the x? Man, that one's difficult. Just blows your mind how hard that one is. And, of course, what else is going to come with this? What's the derivative of natural log? 1 over x. So, what are they going to ask you to do the antiderivative of? They're going to give you 1 over x, which means the antiderivative of it is going to be It is going to be a natural log of x, but there's an extra wrinkle here, though. Okay. Can you have the log of a negative number? Can you guys guarantee me that that x right there in that log is going to be a positive number? No. So therefore, we absolute value it to guarantee that it will be a positive number. Because you have to have the log of a positive number. Okay. That's actually the one that'll catch up the most, because when you see 1 over x, there's nothing about 1 over x that makes you think, hey, I'm a log. It looks like it's a fraction. It does not scream log. So that one will probably bug you for a day or two. We'll be doing a lot more with E and natural log next class. Today is just a teensy introduction. All right, last but not least, how we doing? 4 minutes. You have to prove to be brilliant. Okay. I am going to do a couple basics here. If you have those rules right in front of you that you just copied down, this is a snap. All right, I just want you to integrate that baby, or excuse me, do the antiderivative of it. You should be looking at going, those are all derivatives of something. And if you recall with trig functions, the numbers in front don't do anything but just sit there. So what do I get if I go backwards on a 4 cosine? It would be a 4 sine. Did you get a co? Is that answer a co?
No.
Then it's not negative. Then we'll put the plus c at the end of all of it. This is all one big problem. Okay, so a negative 3 secant squared, the derivative of what gives you secant squared? Tangent. So it will stay negative 3 tangent. We don't need to change the sign. It didn't come out of co. Okay, but the next one, for cosecant cotangent, that's a cosecant. It's a co. It can't, so it needs to have a negative, or in other words, it needs to change sign. So instead of a plus, it should actually be a minus 4 cosecant. And then throw your plus c on the end. Are we done? I need to run a couple others at you here. Yes, we're done with that one. That's it.
I like that. Nothing is too right. Too good to be true.
All right. Suppose this is a little, well, slightly tricky. This is just, I need to show you a couple tricks of the trade here. Can I do this one with trig functions? Why? Multiplying of something times the quantity? Buzz, can't do that. So what do I do? If you distributed it, it would help. Yeah, it would. It would be cosecant squared x, which is a derivative we know, minus cosecant x cotangent x, also something we are well familiar with. And so now, since they're derivatives we know, what do you get when you do a cosecant squared? The derivative of what was cosecant squared? It would be a cotangent, and therefore it's a cos, so it gets a negative. Derivative of a cosecant cotangent is a, yeah, so that actually in the end makes this become a plus cosecant x plus c. I know, I have 40 seconds left and I can't do these last two problems. I'm going to do 2 more problems, guys, that will be posted with the notes. I think if you look at them, you'll be able to figure out what went on. The next one is going to involve using some trig identities. Woo! Yeah! Hope you all are feeling better. You'll be receiving lots of fun messages from me. Bye.
Bye. Hold on. Bye.